Hey, everybody, and welcome to this educational series by the Women of SWPA. I love so much to be able to bring industry together. So I'm Charli Matthews. I am the founder and CEO of Empowering Pumps and Equipment. And today I am working with SWPA, specifically the Women of SWPA and Layla Wilhelm. She is just a trailblazer already in her field. And I'm excited to learn from you today, Layla. I've already watched you in action, kind of teaching and creating other educational items that you use within your company, Crane Pumps and Systems, but also at SWPA now. So we're going to dive into the systems approach to lift station design and construction. The systems approach goes way back for me. And it really does say, you can't just have a pump. You got to talk about the system. So Layla, I'm going to turn it over to you. Let everybody know kind of your background and jump into the systems approach.
Yeah, thank you. So as Charli said, my name is Layla Wilhelm. I'm a product manager at Crane Pumps and Systems and also a proud member of SWPA. I actually participate as the co-chair of the technical committee. And it's one of my favorite parts of working in the wastewater industry. So on the systems approach, it is really a hallmark of how SWPA goes about things. And to jump right in, what the systems approach is a single source responsibility. And it's having a single person who is responsible for providing and coordinating the primary components of the pump station. These components need to work together as a whole to provide a functional station. And as manufacturers, vendors, contractors, engineers, our goal is to provide a quality product and project to the customer free of major issues, and the systems approach can help do that. Single source responsibility directives. These are the main responsibilities of that single person, that single entity. Coordination of key pump station components, ensuring component compatibility, system startup and commissioning, and also future support for repair, maintenance, upgrades. It really brings a peace of mind to the customer that someone's ensured that everything will operate together, especially on those larger jobs, where there's a very large station or many stations with a lot of components that need to be ensured that they're going to cooperate and work together when they get on site. And a way to do this is through a design build contractor. Someone who follows the project delivery and they're starting the project from start to finish, from initial design to installation even. This person is really the source of contact for all of the parties. And this some advantages to that: reduce completion time. It actually can reduce the overall timeline of the project. Can also reduce the overall cost, especially there's not that time going back and forth to make sure that everything's working together. You have someone checking that. And then also just an improved coordination. So some of the benefits, we talked about a little bit, the cost reduction. There's also a level of component quality that comes to this because you're getting the best stuff when you have someone who's double checking that compatibility. They can also coordinate delivery, making installation easier because all of your products are on site when you need them on site. And so you're not waiting for one component here or there. And it can, in the same vein, reduce the overall timeline of the project. This person is also great as a supplier support. They can have the conversations with suppliers about delivery and about getting things on site, making sure that compatibility. It also helps that it's a one contact, one relationship kind of thing, where there's no question if you have a question of who to talk to. You know exactly, if I'm a manufacturer and I'm working with this person and I have a question of, well, do I need to paint it pink or purple? I can ask that person kind of thing. And so it benefits all of the parties in the project, not just the customer. And so what does that delivery look like that they're coordinating? So sometimes it is a prefabricated basis. Sometimes it's all of the parts getting there at the same time and being put together at the same time. These are just some examples of what kind of you might see in that submersible wastewater world. And so next, we want to go into the components that make up that system. So these are just some examples of different types of basins and stations that are out there. These can be prefabricated, they can be modular, they might be all assembled on site. They are usually duplex, especially in the municipal world, but there are possibilities for larger, triplex, even quadruplex. This is mostly for redundancy purposes. These stations are often critical. If a pump goes down for whatever reason, you have a backup. But it also lends to energy efficiency. A good example is a station where you may have a single 50 horsepower pump. You can replace that station with two 25 horsepower pumps. And while the cost of the two stations may be similar overall, those 25 horsepower pumps are going to use less energy when operating than that 50 horsepower pump would, especially when they're alternating. And so that can be an energy cost savings for a customer. So to talk about the individual components, the biggest part is the basin itself. Basins come in fiberglass and concrete. Those are the most common materials. There are some other materials out there, polyethylene, and there might be others that aren't coming to mind right now. And they come in all different shapes and sizes. You have rectangular or square. Typically, your fiberglass ones are round. And like I said, sometimes they're prefabricated and shipped to the site. Sometimes they're fabricated in place, especially with concrete. Note on this picture right here in the second from the left, we've got those blue basins. They have an integrated valve vault. So does the picture on the far right. That has an integrated valve vault. What that does, and I'm going to talk about it a little bit more later, but it makes excavation easier. It makes piping easier. And often something to think about with excavation is it hard to excavate there? Is it a rocky terrain? Is it a particularly hard soil? Is it someplace where the frost line is very low? So you need to take into account that depth. So things you can do to make excavation easier as someone designing or manufacturing a product is going to make your customer's life easier. So the next part is the basin cover. This is the lid for the basin. Basins have overall minimal above ground footprint, as you can see in some of these pictures. Most of what's going on is underground, but that cover is really one of the only components. There are many different types of access covers out there. They come in different materials, different sizes, different shapes. Sometimes they are complete all metal, maybe steel or aluminum. Sometimes they are cast into concrete. One thing that they do almost always include, whether it's part of the cover itself, it's another component, is that fall protection. So that's those orange grates that you see in the top left and the top right pictures. When you're working around a basin, you might have your back to it when you're looking at the panel, especially like in that top right picture. You might, be moving things around. Sometimes these basins are fairly deep and it can be pretty dangerous around them. So that fall protection is really critical. So we are the Submersible Wastewater Pump Association. So we have to talk about pumps at some point. Submersible pumps come in all different sizes and all different types. Specifically, the ones that we talk about at SWPA are grinders, non-clogs, or solids handling, and choppers, and sometimes cutters. These can range in size from little 1 horsepower residential pumps to greater than 1,000 horsepower non-clog pumps. As you can, some of them you can pick up with one hand, and as you can see on the picture on the right, they can be bigger than you are. Discharge sizes can range from 1.25 inches in some of your small residential grinders to over 36 inches. So really a really large range, and it's all about finding what is the best fit for your application, your capacity. Guide rail systems. So this is something that makes submersible pumps easier to use. How these guide rail systems work is there is an elbow that is attached to the floor of your basin, whether it's concreted in, epoxied, bolted. Different manufacturers have their different recommendations. And there are rails that go from that elbow to the top of the wet well. And there's some brackets usually for stability. And this allows the pump to slide up and down. There's an attachment on the pump, and it'll lock into place on that elbow, and it completes the discharge piping. This makes for easy access to the pumps, whether you're when you're repairing them or maintaining them, and it makes for easy installation as well. Often these, with some of the pump sizes they're fairly heavy too. You need to utilize a hoist or a crane truck, like you can see in the one picture. And so that guide rail makes it a little bit easier to make sure you're putting it in the exact right spot in the wet well as well. Valves. So pump stations need valves for various reasons, the major ones being isolation and backflow protection. Valves can be located in a couple different spots. They can be in the wet well itself, or they can be in a valve vault, like we looked at a little bit before. There are a lot of local codes about where valves can be located and what kind of valves can be used. And there's also hazardous area classifications that need to be taken into account. So when selecting and designing where your valves are going to go or what kind of valves you're going to use, be sure to pay attention to those codes and that classification. So first, internal valves. These are valves that are integral to the discharge piping of the station itself. As you can see, we've got a simplex on the left with a single pump. It's only going to have a single, it's probably only going to have a check valve. It might have an isolation valve, whereas your duplex and your triplex, the need for the isolation valve is more critical, because if that pump goes out of service for some reason, you're repairing it, replacing it, you need to be able to isolate that discharge piping so that when the other pumps are running, they're not just pumping back through that piping. Check valve for a similar reason. Note that in internal stations, valves internal to a station, check valves can be harder to operate because first, it is a confined space area, and you need to be confined space trained and have permits to be able to enter them. So some manufacturers offer things like ledges, which can be seen in the top left, or there are extension handles that can make it easier to operate those valves from outside the station. There's also external valves, like the valve box we talked about. These are it's almost like another basin. It might be concrete, it might be fiberglass. Sometimes it's directly attached to the basin. Sometimes there's piping going in between the basin and the valve vault. And this is just a place for the valves to sit, typically underground. And as you can see, we call it a non-return valve here. Another word is a check valve, and you've got your isolation valve. It also has a drain in case for any reason these valves are leaking. That drain will actually often go back into the basin, so it doesn't just sit there. And sometimes too, you'll see a small sump pump in these valve vaults that will go back to the station as well. You can also have an above ground enclosure that houses your valves. In this particular example, this one also houses the control panel. So it protects your control panel from the elements as well as your valves. This is very easy access. It's not confined space, so you would be able to operate them very easily. But this can be more expensive. It's another piece of equipment. It's usually another concrete pad to pour. So it's got its positives and negatives. This is also really good for, again, places where excavation is hard, rocky terrain, hard soil, environmental concerns. This would be great for that type of application. And next is control panels. Panels are, they can be anything from super simple to very complex. They really are subject to what the customer wants. It could be as simple as an on-off switch, or it could have a huge sophisticated telemetry system with monitoring everything the pump has to offer. These enclosures are NEMA graded, and that is selected based off of the location they're in, the environment, the kind of weather they're going to see. There is also hazardous classifications taken into account there, so explosion-proof ratings. These panels also have to weather the elements. So sometimes they have air conditioning where if it's in a hot environment, or heat in a cold environment, and sometimes even lightning protection in a place that gets really heavy thunderstorms. Because of the varying complexity, panels can be very low cost or very expensive. And this is really dependent on what the customer wants the panel to do. They are typically close to the station, like you see here. But sometimes if for some reason that station's in a place that's not safe for the panel or not ideal for the panel, they can be placed at a distance. Last is level controls. They're also varied just like panels. You can range from a classic ball float, like is in the top left. There are pressure transducers, a segmented pole type, ultrasonic, bubblers. I think there's even a radar type system out there. Pretty much level controls monitor the liquid level in the station. And when that level is reached, it triggers an action of some sort. That might be turning the pump on, turning the pump off, setting off an alarm. A challenge that faces all level controls is fog, fat oils, and grease. That sticky fog likes to stick onto the ball floats, onto that segmented pole type, and it can make these measurements inaccurate when they're sensing the level. The ball floats will become larger and then will turn off and on at the wrong time. So that's something that you have to take into account when designing stations. Some of them do better with fog, some do worse. Each of these technologies do have its positives and drawbacks, so it is really about finding the best one for your particular application. So to wrap up on the systems approach, it is the supply and unity of responsibility, having those complex pumping systems designed and trained by a professional, keeping within the project budget, so again, reducing that cost, ensuring component compatibility, and ensuring that that equipment ships together from the single location to the job site. So pretty much anywhere from a basic station to a complex station, we can focus on the compatibility of the components and keeping everything tight and delivering a quality product to the customer. And that is all I had. Thank you for joining us today. And my information is on the screen if you have any questions.
Yes. Thank you, Layla. I felt like that was so great to understand a kind of a complex system in a basic way. And so that's always a great thing. So this what do they say? That's a really good teacher if they can explain something and make it, super simple to everyone. So I felt like I learned something. Hopefully everyone else does. And if you kind of wanted that next step, you wanted to kind of dive into the pumps, for example, being empowering pumps and equipment, we always want to dive into the pumps a little bit more. Layla can definitely help you with that, but also we are going to have an event coming up November the 8th and 9th. That is epic. It will be at the Water Tower, and the Women of SWPA are going to do several technical sessions. The Women of SWPA will be there on November the 8th, talking to you about choppers and grinders, the water solutions, and really just diving into, grinder pumps and pressure sewers, and really just can answer your questions. So Layla will definitely be there presenting, and we have several other of the SWPA members. Now, I didn't really dive into SWPA at the beginning. Layla, you did a great job. This is the Submersible Wastewater Pump Association. So that in itself, they're really trying to educate and are educating the workforce and how you use these products, but also just trying to solve problems out in the workforce. So I really love the family approach that and kind of culture that is there with SWPA. And it was really wonderful to meet you, Layla, and see, how you're plugging in and really driving some of that educational change there to get out and do some things that are a little different. Yeah. So anything else that you wanted to leave our listeners with? Okay.
I guess the only thing is, if you do have some interest in SWPA, you can go to the website at swpa.org and reach out there. Also, if you have any questions, you can reach out to me. We are continuously trying to grow and do what we can to help the wastewater industry. And so if you think you'd be a good candidate to attend some of our trainings or meetings, we'd love to have you.
Yes. And the next one that I know about is coming up in December. And we definitely want to bring y'all's attention to that because it's very hands-on. So super excited about that and just the other opportunities for training. I know you've got digital versions of that, trainings that are housed there on the website, but also just coming in and meeting the industry. So look forward to seeing y'all in Beaufort, Georgia, and then after that in Chicago. So thank you, Layla, for being here with me today.
Thank you. Yeah.